NASA has issued an alert. On March 14th, the moon will take on a deep red glow, and this time, something unexpected could happen. As Earth's shadow completely covers the moon, millions will witness a total lunar eclipse. No telescope needed, just your own eyes to experience the eerie sight. But here's where things get intriguing. While the moon undergoes its transformation, something else might appear in the sky, and you won't need any special equipment to see it. As long as the sky is clear, you're good to go. Want a closer look? Binoculars or a telescope will enhance the view. The best part? No need to battle crowds. This isn't a rare comet that only a few will glimpse. It's a breathtaking celestial event visible to anyone in the Western Hemisphere who simply looks up. But what happens next might leave you speechless. First, the Penumbral Eclipse begins. That's when the moon enters the outer part of Earth's shadow. Honestly, it's not much to look at, just a slight dimming that most people won't even notice. Next, things get interesting. The partial eclipse kicks in as the moon starts slipping into the darker part of the shadow, making it look like something is taking a bite out of it, slowly covering more and more. Then comes the main event, totality. This is when the moon is completely engulfed in Earth's shadow and turns that eerie burnt orange red. That color? It's basically every sunrise and sunset on Earth happening at once, reflected onto the moon. Talk about dramatic lighting. Once totality ends, the whole process plays in reverse, slowly revealing more of the moon as it moves out of the shadow until it's back to normal and the eclipse is officially over. But wait, there's more. As you look up at the night sky, be on the lookout for some special cosmic visitors. Jupiter and Mars will shine brightly in the western sky, easily visible even without a telescope. Meanwhile, the moon will journey through the constellations Leo and Virgo, which will stand out even more thanks to the dim moonlight during totality. But the true wonder isn't just in what you see. It's in the deeper story behind it. Exploring the science and history makes the experience even more captivating. Lunar eclipses have fascinated humans for thousands of years. Ancient civilizations saw them as omens. Some thought they meant a king was about to fall, while others believed they were warnings from the gods. The Inca believed the jaguar was eating the moon and would come down to Earth to feast on people next, so they would shout and bang on drums to scare the beast away. Pretty dramatic, right? Meanwhile, in ancient China, they thought a celestial dragon was attacking the moon, so they made all kind of noise to drive it off. Basically, a lot of yelling and banging things together. These stories show just how spooky lunar eclipses seemed before people understood what was really happening. Would you believe that the moon's shade of red during an eclipse isn't always the same? Sometimes it glows a deep blood red, while other times it takes on a rusty orange hue. This color shift is influenced by factors like dust and pollution in Earth's atmosphere. If a major volcanic eruption has recently occurred, lingering particles can make the moon appear even darker and redder. So, if this eclipse has an especially haunting look, you can thank Mother Nature for the dramatic spectacle. For centuries, people looked up at the moon, marveling at its eerie glow and the way it seems to shift and change. But every now and then, it does something that makes even the most skeptical observer stop and stare. It darkens, then turns a deep, almost unnatural red. Some call it haunting. Some say it's a bad omen. NASA, on the other hand, calls a lunar eclipse, and they're already sounding the alarm for a big one coming up on March 14th. A lunar eclipse occurs when Earth positions itself between the sun and the moon, preventing sunlight from reaching the moon and casting a shadow on its surface. Unlike a solar eclipse, which is only visible from certain locations, a lunar eclipse can be seen from anywhere on Earth's night side. If you're in the right spot at the right moment, you'll have a perfect view. The moon turning red is fascinating, but its orbit holds an even bigger surprise. Instead of a perfect circle, the moon follows an elliptical path, meaning its speed and distance from Earth are always changing. On top of that, Earth itself moves around the sun in a slightly tilted orbit, making things even more complex. That's where NASA steps in, using Kepler's laws of planetary motion and Newton's laws of gravity. Yes, the apple falling guy, to precisely predict when and where these cosmic events will take place. Astronomers can predict these celestial events with astonishing accuracy, thanks to data from space telescopes, lunar satellites, and advanced computers processing calculations at incredible speeds. Although the moon orbits Earth roughly every 29 days, lunar eclipses don't happen monthly. That's because the moon's orbit is tilted about 5 degrees relative to Earth's, causing it to miss Earth's shadow most of the time. However, when the moon reaches a specific point in its orbit known as a node, everything lines up perfectly, setting the stage for an eclipse. Not all lunar eclipses are alike. Some are partial, where only a section of the moon enters Earth's shadow, while others are penumbral, meaning the moon passes through the faint outer edge of Earth's shadow, resulting in a subtle dimming. The most breathtaking, however, are total lunar eclipses, when the moon is fully immersed in Earth's dark umbra, glowing in a striking shade of red. But why does the moon turn red? The answer lies in Rayleigh scattering, the same phenomenon that creates the vibrant colors of sunrises and sunsets. As sunlight passes through Earth's atmosphere, shorter wavelengths like blue are scattered away, allowing the longer, redder wavelengths to filter through and bathe the moon in a reddish glow. The exact shade can vary, influenced by factors such as air pollution, volcanic activity, and atmospheric conditions, ranging from a soft burnt orange to a deep blood-like crimson. NASA doesn't forecast eclipses just for the sake of it. Each one offers a valuable scientific opportunity. By observing how sunlight bends through Earth's atmosphere and reflects off the moon, researchers gain a fresh perspective on our planet's atmosphere. This same technique is also applied to studying exoplanets, helping astronomers determine the atmospheric compositions of distant worlds. Eclipses serve as natural testing grounds for space equipment. Scientists use these events to study how instruments react to sudden changes in light exposure. Lunar probes and space telescopes gather data that refine sensor accuracy, improving future space missions. Because eclipse conditions mimic certain aspects of deep space travel, they offer a valuable chance to calibrate and enhance tools for cosmic exploration. Another major challenge? Communication. During a total lunar eclipse, Earth's ionosphere undergoes significant disruption, which interferes with radio transmissions. This poses a serious problem for future lunar bases that rely on Earth for guidance and support. If an eclipse temporarily severs communication, astronauts could find themselves isolated at the worst possible moment. To ensure their safety, they must have autonomous systems capable of handling emergencies without input from mission control. That means operating in complete darkness, in extreme cold, and without the ability to call for help. A scenario that demands cutting-edge advancements in onboard AI, navigation, and contingency planning. Energy storage is another critical hurdle. While batteries are essential, they have limitations, especially in the harsh lunar environment. The primary concern is ensuring that astronauts have enough stored power to survive prolonged eclipses when solar energy is unavailable. This requires the development of ultra-efficient energy storage solutions that can function reliably in extreme conditions, an engineering challenge even here on Earth. But there's a silver lining. The breakthroughs made in space-grade energy storage could revolutionize power systems on our planet, paving the way for more efficient batteries and energy grids in the future. Some scientists suggest that lunar eclipses may influence the moon's thin exosphere in ways we don't yet fully understand. During an eclipse, interactions between charged solar particles and the moon's surface could lead to unexpected effects, potentially impacting dust movement and long-term surface changes. While the moon lacks an atmosphere like Earth's, it still responds to the sun's presence or absence in ways we are only beginning to explore. As more countries and private companies join the space race, understanding lunar eclipses becomes increasingly crucial. Any mission, whether crewed or robotic, must factor in these events, as ignoring them could result in equipment malfunctions, mission delays, or even more severe consequences. Every study of lunar eclipses brings us one step closer to making space exploration not just possible, but sustainable. As humanity prepares to return to the moon, these eclipses will become a routine aspect of lunar operations. Astronauts must adapt, engineers must innovate, and mission planners must anticipate every challenge. What was once a rare and mysterious event will soon be another obstacle to overcome, because exploration is about facing the unknown, preparing for the worst, and transforming the impossible into the everyday. The moon glows red, the sky darkens, and temperatures plummet. Could lunar eclipses introduce a new challenge for future missions?